Hello, everyone. I'm sorry that I have to be gone today, but the show must go on regardless. So we're going to start by reading off the answers to yesterday's homework. So have that out so you can mark the ones that you missed. Try to find your errors, and if you can't find them, then circle them and ask me when I return. So have out the homework for 1.2. If we need to pause the video for everyone to be ready, go ahead and do so. Otherwise, I'm going to continue forward. So 17. Z equals 3, 20, H equals -9, 21, C equals 5, 24, R equals -6. And 25, K equals 45 degrees. The other angles would be 45, 90, and 45. 29, the equation translates to 2n plus 13 equals 75, and therefore n would equal 31. And number 31, the equation would be 8 plus n divided by 3 equals -2. You solve this by first subtracting 8 and then multiplying by 3. 35, the equation would be 30 times 8.75 plus 11t. If you solve for t, you'll find the time is 12.5 hours. Question 40, the error was when using the distributive property in the second step. The second term should be positive. When you distribute, the second term should be positive. In 57, it would be m plus 5. In 59, the answer is -2. And 63, it would be A. So that was it for 1.2. At the bottom of that homework, I'd like you to try this warm-up question. We're going to continue trying these throughout the year, especially first semester, until we're all comfortable with this type of scenario, converting a word problem to equations and solving. So here's the situation. It says a consumer is considering two cell phone companies. The first company charges $600 for the phone and then $60 each month for data. The second company provides a free phone but charges $80 per month for data. How long would it take for the two deals to cost the same? So I would ask that we pause the video now and give people maybe a minute and a half to solve it. You're going to need to define a variable, and this is asking how long will it take. So we're measuring months, so maybe m can be months. That would be your variable. So pause the video now, give everyone maybe a minute and a half to try it, come back after everyone's had a chance to try it, and we'll see how we did. Okay, here we go. Here's the first one. It says the first company charges $600 a month plus, or no, $600 for the phone and $60 each month for data. That $600 for the phone is a one-time fee. So it's 600 plus then $60 each month. We want to know when is that going to equal the second plan. The second plan provides a free phone, so $0, but then charges $80 per month. So 0 plus 80m. There's our two equations. Now we need to solve. We look to see if there's any simplifying. There is not. There's no distribution. There's no like terms on the same side because I've got number, variable, and variable. So my next step is to get same side, get my variables to the same side. I can already see all my numbers are on the left. So I'm going to get all of my variables to the right. By subtracting 60m, I then get 600 equals 20m. If I take 600 and divide by 20, I will find that it will take 30 months for the two plans to be equal. After 30 months, which plan is going to be the cheaper one? Well, the red one, because it charges less per month. If you have the phone for less than 30 months, so that'd be 2.5 years, you divide by 12 in order to get months into years. If you have it for less than 2.5 years, then the better plan is going to be the blue plan. Okay, there we go. Good day. So this whole chapter is on solving equations. So far we've solved 1 and 2 step equations. That was day 1. Then in the prior lesson we solved multi-step equations, steps or equations that might have 2 or more steps. And today we're going to be solving equations that have variables on both sides. Kind of like this one did, but with just more steps involved. So you need your note packet out too. This is section 1.3, day 1. We're splitting it into 2 days. Tomorrow is going to be more of just a review day. So here are the 3 steps. I introduced these a few days ago. They are simplify, same side, solve. Simplify usually means distribute and combine like terms that are already on the same side. Like terms on the same side. Yesterday it also meant clear fractions. That's going to be kind of not an issue going forward though. It's mostly going to be distributing and combining like terms that are on the same side. Then you need to get your like terms to the same side. make one side be for your variables, one side be for your constant terms. Constant terms are number terms. We call numbers constant because numbers don't change. The number 5 is always the number 5. And then your last step is solve for your variable. It's almost always a division step. Sometimes it might be a multiplication step. So here we go. First example. First thing we're going to do is look to simplify. Is there any distribution? Is there any like terms that are on the same side? Well, I've got number, variable, variable, number. This is kind of my line that I'm looking at, and there's no like terms on the same side. It's kind of a mismatch. So I don't have any distribution. I don't have any like terms on the same side. My simplify step is really done. Now I need to get my like terms on the same side. And it technically does not matter which side you make for your variables and which side you define for your numbers. However, the common suggestion is to get your variables moved first and to move all of your variables to the side that has the most positives. Then your number in front of your variable will have a positive coefficient, and it just makes it less likely that you're going to make a mistake. So I asked myself, which is more positive, positive 4x or negative 8x? Well, clearly the positive 4x. So I'm going to get all of my variables to the right, and that will leave the left-hand side for my number terms. How am I going to do this? Well, I'm going to add 8x. When I add 8x, no more variables on the right. They're all going to be on, or on no more variables on the left. They're all going to be on the right. I then get 7 equals 12x minus 17. I don't have my numbers to all of the left yet, so I need to add 17. Then I'll have 24 equals 12x. And I've organized then all of my variables to one side and all my numbers to one side. My last step is to solve. I always solve by undoing what's happening to x. X is being multiplied by 12, so I need to divide by 12, and I get my answer that 2 is equal to x. So that means x must be equal to 2. Example 1, done. Simplify, same side, solve. Example number 2. I'm going to look if I can distribute. Can I distribute a fourth through? Yeah, I can, because each of these are divisible by 4. So I'm going to do that. So distribute first. What's happening to everything else while this 1/4 is being distributed? It's just hanging out, chilling. 1/4 times 16. Well, 1 times 16 is 16. So I get 16 fourths. So I'm going to write that. I have 16 fourths. Some of you might know that's just going to be 4. Plus 1/4 times 60. Well, that's going to be 60 fourths. The left-hand side is still just waiting for the right side to get its stuff together. 16 divided by 4 is 4. 60 divided by 4 is 15. And now I'm here. I don't have any like terms on the same side because I got variable number, variable number. It's a mismatch, so I'm done with step 1. Now I need to do step 2. Get all of my like terms to the same side. So like I said, the common suggestion is let's move our variables first and let's move them to the side that has the more positive. So what's more positive? Positive 4, positive 9. Well, positive 9 is more positive. So I'm going to move all of my variables to the left and get all my numbers to the right. So I'm going to get rid of the variables on the right so all the variables can go to the left. Subtract 4x, I get 5x then minus 5 equals, these will cancel and make 0x's. 15. Now I need all my numbers to the right, so I need to get rid of them on the left by adding 5. If I add 5 to the left, I need to add 5 to the right. I then get 5x equals 20, and now I have all my variables to one side and my number terms to one side, so I'm done with step 2. Last step is solve. Divide by 5, and I get then x equals 4. Simplify, same side, and solve. Can I give you a chance to try one? So pull out your whiteboards. Your problem, kind of zoom in and make it a little easier to see, is this guy. But applying the same steps. You simplify, so you're probably going to have to distribute. Then you need to get your like terms to the same side. Then you're going to need to solve. So pause the video now, maybe for a minute, minute and a half. Give everyone a chance to try. Unpause it when you want to see what the answer is. Okay, here we go. I'm going to go kind of fast. First step is simplify, distribute. X plus 5 is just waiting. We then get 10x plus 2 times 7 is 14. Don't forget the 2 has to distribute to the 7. Now I need to get my variables to one side, so I'm going to subtract x because 10 is bigger than 1. So I get 5 equals 9x plus 14. I need my numbers to the same side as well, so I'm going to get 5 minus 14 equals negative 9. These will cancel out. And then do my last step of undoing what's happening to x. We call that the solve step. And I get that x is equal to negative 1. So that's what your work should have looked like. Okay, that's the first half. Second part has to deal with unique situations. So unique situations. The situations you're looking for are the two following ones. If we end up with a false statement, like all of our variables go away, and we get something like 2 equals 3, which is clearly not true, then we're going to say no solution. We say no solution because the equations weren't even balanced from the get-go. There's no value that you could put in for the variable that will ever make the equations balanced because they didn't start out balanced. It was actually a false statement from the get-go. The other unique situation you can have happen is if your variables disappear and you end up with a true statement. A true statement is something like 3 equals 3 or 0 equals 0 or negative 11 equals negative 11. Then we say there are infinite solutions because you could pick any value you'd like for x and it would be a true statement. Another way of saying infinite solutions is you can say identity, which means really the exact, which means the one side of the equation was identical to the other side of the equation. It didn't matter what the variables were. So those are our two unique type of situations that can occur. So examples of all three. First one looks like this. Well, I still need to follow the same steps of simplify, same side solve. So I'm going to simplify by distributing first. I get 3x equals 3x plus 12. Now I've got variable number. I need my variables to the same side. My numbers are clearly already on the right, so all my variables need to go to the left. However, when I do this, I end up with them canceling out, and I get 0 equals 12. That is not a true statement. Because it is not true, we say there is no solution. You could search day and night. You are never going to find a value for x that you could put into the original equation that would make it true. The reason why is because the equation actually never was true. This never was an equality. That left side would never have equaled the right side. It was a false statement from the get-go. It's kind of like a lie. Situation number 2. Need to simplify first, which like I said is the distribution step. So distribute 5n plus 10 equals, now we need to distribute with the 3/5. I can distribute because fifths will cancel with 5 and 10. 3/5 times 5. If I have 3/5 and I multiply by 5, that's going to be 15/5. Plus, I still need to distribute to the 10. If I have 3/5 and I multiply by 10, well, 3 times 10 is 30, so that's going to be 30/5 n. Then I just clean up those fractions by dividing it, and I get 3 plus 6n. Now I go solving. I've got variable number, variable. I move my variables to the side that has the more positives, which in this case is going to be the right, so I need to get rid of them on the left. I will then end up with 10 equals 3 plus 6 minus 5 is 1n. We just put n. Now I need my numbers to the same side and subtract 3. I get 7, and 7 equals n. So this is the standard case that we run into. When the variable doesn't disappear, we end up with one solution. That's the more typical case. I would say this one probably happens like 95% of the time. You get one solution. Last case looks like this one. I need to distribute first, simplify. So when I go simplifying, I distribute my 4. Left side is just waiting. 4 times 2w is 8w. 4 times a half is 2, and you might notice, look at the left side and look at the right side. You should already realize they're identical, so this is going to be an infinite solution case. But let's say you're in robot mode, you don't realize that, so you continue on with the typical steps of same side and then maybe solve. So you subtract your variable to get rid of it on the right to maybe move it to the left, but they cancel out on both sides. So you get a statement like 2 equals 2, and 2 equals 2 is a true statement, which means that there are infinite solutions. You could pick any number you'd like, and if you put it into the original equation, it would be a true statement. You could pick, 9. If you put 9 in for w on both sides, you're going to find that they're equal to one another. You could pick 18.36. If you put that in for w on each side, it's going to be true. The reason why it doesn't matter what variable or what number you put in for the variables, because the variables are going to cancel out. You could put anything you want in there. And because anything would work, we'd say there are infinite solutions, there are infinite options, and there are all three scenarios. Standard one is the middle one. Your variable exists and you only get one answer. If your variable disappears, you're then in the unique situation land. You're either on the left or you're on the right. If it's a false statement, it means no solution. You could never find a value that would work. If it's a true statement, it really means any value would work for your variable, so there are infinite solutions. Gonna give you a chance to try these. So pull out your whiteboard, last practice for the day before the homework. Make sure you're doing it right. Simplify, same side solve. See if you can determine, is this going to be the typical one solution case? Is this an infinite solution or no solution? Try both of them. Pause the video now for maybe 2 minutes. Unpause it once everyone's had a chance to try. Okay, here we go. First thing you'll do is distribute. Then you then get 7x minus 7 times 5 is 35 minus 2x equals 5x. If you look, you've got variable number, or sorry, last one's a variable. Obviously, 5x is definitely a variable. If you look, though, you've got like terms on the same side. They're right here, 7x minus 2x. You can combine those. That's going to make 5x minus 35 equals 5x. You need to move your variables all to the right, so get rid of them on the left. But when you do so, they're going to cancel each other out, and you get negative 35 equals 0. That is not a true statement, so it means that there is no solution. There was no value for x that would ever make the equations true. Right side, distribute your 3. You're going to get 6x minus 15 equals 5x minus 15. You get your variables all to the left by getting rid of them on the right. You then get x minus 15 equals negative 15. You move your numbers to the right, so add 15, add 15. This cancels, but that doesn't mean there's no solution. There's still an x here. X will just happen to equal what is negative 15 plus 15? 0. That's still an answer. X equals 0. 0 is still a number. So if you put 0 back into the original equation, it would be a true statement. And that is it for today. Your homework is going to correspond with day 3 in your assignment sheet. And the answers for that are right here. If you'd like to leave the video paused at this point, you could check your answers as you work. Otherwise, have a good day, and I will see you when I get back.